Complex numbers are numbers that involve the number I, and where I is the square root of -1. Here are some problems that involve I. First of all, write using I, square root of -72. Now what this will be I square root positive 72. So a negative number under a radical now, we take care of that by writing I outside the radical. Sometimes we write it before the square root, sometimes we write it after. It depends on whether it's going to look like I is under the square root or not, because I isn't under the square root. That's why I write it in front right here. Now I'm going to simplify square root 72. This will be square root of 36 times 2. So I end up with 6. That's the square root of 36. I square root 2. So this is how I take square roots of negative numbers and rewrite them using this complex number I. Now let's take a look at some addition, subtraction, multiplication, and division with complex numbers. Here I've written subtract. I have 6 plus 7i, subtract 4 plus I. So what I'm going to do first of all is take care of this subtraction symbol, remove these parentheses, and change the sign of each thing inside. 6 plus 7i minus 4 minus I. Now I can combine similar terms in the same way that I combine similar terms with polynomials. 6 plus -4 will be 2. 7i plus -1i will be 6i. So this is the complex number I get, 2 plus 6i, when I subtract 4 plus I from 6 plus 7i. So here's the difference of two complex numbers, and it turns out to be a complex number. Here's our next problem. I want to multiply 6i times the quantity 4 minus 3i. I'm just going to do it by applying this distributive property. 6i times 4 will be 24i minus, that's that subtraction sign, 6i times 3i will be 18i squared. Now, I squared is going to be -1, so I can simplify this further and write it as 24i subtract 18 times -1. Now, usually we write the real number part first and then the complex, or the part that involves I, second. So -18 times -1 is positive 18 plus 24i. So this kind of multiplication works just the same as multiplication with polynomials, except that if I run across an I squared, I replace it with -1, and that allows me to do a little more simplification. Problem number 4, I have 2 plus 5i quantity squared. So I square the first term, 4, square the last term, 25i squared, and then I take twice the product of the two terms. This is 10i times 2 is 20i. So I square this expression in the same way I would square a binomial, and now I have a little more simplifying I can do, because I squared is -1. So I have -25 plus 4, which will be -21, plus 20i. So that's kind of nice. Here I square a complex number, and I end up with another complex number. So the only difference between this and multiplication with polynomials is that every time I see an I squared, I replace it with -1, and that gives me a little more simplification to do. -25 plus positive 4 will be -21 plus 20i. Here's a division problem. 4 divided by 2 minus 3i. We'll accomplish this by a method similar to rationalizing the denominator. We'll multiply the numerator and denominator by the conjugate of the denominator. What this does is gets rid of all the i's in the denominator, because remember, I is a square root. It's the square root of -1. On top, I have 4 times 2 is 8, plus 4 times 3i is 12i. On the bottom, I have 2 minus 3i times 2 plus 3i, so it's the square of the first term, 4, minus the square of the last term, 3i squared, which is 9i squared. Now, I squared is -1 times -9 is positive 9. I get 8 plus 12i divided by 4 plus 9. That's 8 plus 12i divided by 13. So I'm going to write that over here. 8 plus 12, 8 plus 12i, all divided by 13. Now, if I want to write this as a complex number in standard form, it would be 8/13 plus 12/13 I. That's writing it as a complex number in standard form, this is also the correct answer right here. And I've divided 4 by 2 minus 3i, and I end up with this complex number. The key to division is really in multiplying the numerator and denominator by the conjugate of the denominator.